Hello and welcome back to our series where we are building a people and culture management system. Particularly, we're working on our compensation dashboard, more specifically, our market comparison for our salaries. This series is brought to you by Prairie HR Solutions. My name is Jake Finger, founder and principal consultant here at Prairie HR Solutions. And in this video, we are going to create some more helper functions for our calculations. So what we have going on here is the average experience field down here in the average base pay, as well as our job title field, mirrors whatever value is up here and down here and here. So what we're going to need to do now is take that data and find the median, because right now this is just the average. It's just a regurgitation of this value, but we don't want the average, we want the median. Oftentimes they're used interchangeably, but um, they can be vastly different depending on what data is coming through. And we'll get to that in just a second. So we're going to need to find the median of our data, of our salary data. And then we're also going to need to find these percentiles. And that's where those helper functions are going to come in. We're going to create a helper function to find the median. And then we're also going to create a helper function to find the percentiles, 10, 25, 75, and 90. And the way we're going to do that helper function is we're not just going to hard code 10, 25, 75, 90. What we're going to do is pass that as an argument to where we can change that dynamically if we don't want 10, 25 or whatnot. If we want, say, 0, 25, 75, and 90 or minimum. So we just have it set up right now for our 10 because that's the way our survey data came in. But obviously you can change this up however it is your compensation structure is, or if you're not using bands, then you can change it however, but you'll have the code snippets to do these calculations here. Now, this isn't going to be heavy on a statistics tutorial. We're not going to go into how to manually find the median or each one of these percentiles. We're just going to write the code to do so. So let's go ahead and talk about what an average and a median is. There are times that it's used interchangeably, but they are different. So obviously the average or the mean is the sum of all the values divided by however many values there are. And it's useful when all these values are kind of spread out equally amongst that average point, that mean. So if all the data was right here, kind of hanging around out here in the center, because median and average is both a measure of central tendency, then that's fine. Then it's useful. But now let's look at, let's see, where's the one that gives me heartburn? Now this isn't real data. This is all randomized data for those of y'all who haven't been following along throughout the series. Project Manager. Project Manager is the one that gives me heartburn. And the average here, you'll see, is 99,000. So that's the average pay here. But it doesn't really give a full picture. And that's where the median would come along. The reason why it doesn't give a full picture is because we have an outlier. And that outlier is this employee way up here. For whatever reason, they joined the organization a little over a year ago, and they're making a substantial amount more than all our other employees. So it's bringing the average upward to where the median would be more down here. And what's helpful of that is if you just look at this, once we get it done, if you look at this and you say, okay, the average pay is 99, but the median pay is, say, 70 something, you're like, okay, what in the world is really going on here? Why is there such a difference? You'll know that there are some outliers, that you have some employees that are paid substantially different. And if they're past, that 2 standard deviations, then you start running into some discrimination issue allegations. So that's the difference between our average and our median. And both measures of central tendency, but they can be different. They can be the same, but they can be different. And that's the reason why in compensation, you'll see not necessarily the average pay, but the median. And the median essentially takes into account the central point better when you have outliers. And in compensation, you typically will have outliers. So let's go ahead and jump over to our code and start writing these helper functions down. So I'm in there, our analytics file. And the first one we're going to do is let's create a function to calculate our median. Calculate median. Here we go. Now this median is going to need to take an array of numbers. So let's just pass that data to it and call it, let's just call it data. Something simple. And what we're going to need to do with this data is first put a check in there to make sure it is an array and it's not an empty array. And we've done this before. We did this with our calculate average, for those of y'all who have watched that. And how we do that is we create a simple if statement. And what we're going to want to check is if this data is an array. If it's not an array, we want to give an error. So how we can do that is we can essentially construct an array, and then we can use this dot is array, and what we want to check is that data, and if it's not an array, this will return true. And we also want to check or this data dot length is equal to 0. So if it's not an array, and if it is an array but there's nothing in it, then we want to produce an error. And we could log it, we could console log it, but what I'm going to introduce you to is something that is common, and you'll probably see this throughout like JavaScript code if you're looking, and that is called throw new error. And it is simply what it is actually saying. We want to throw a new error with a message to the interface, whether it is a logger, whether it is a console log or whatever. So we can just simply type throw new error, and then we need to give it a message. And that message we want it to throw is simply input. Input must be a non-empty array, something like that. So if it's not an array, or it is an array but it has nothing in it, it's going to throw this error right here. And whatever it is that we're looking at, this is great for debugging. All right, so now let's get into the meat and potatoes. So first thing we're going to do is sort the numeric array in ascending order. And how we're going to do that is the same exact way we did this. So this is sorting it. So let's create a constant. We'll call this constant sorted. And what we're going to sort is that data, and we need to create a loose copy of that, a shallow copy. And you'll remember it is exactly the same thing. Anytime you're sorting numbers, this is a great little code snippet line to keep. Sort, and we're going to do A, B, and then we're going to run an arrow function, A minus B. So what this is going to do is this is going to sort this array in sequential order since it's a number. Okay, then what we're going to need to do is take that length and divide it by 2. We need to find that middle point. And for that, we can store that in a variable. We'll just call it mid. And to do this, we will do math floor. And what we're going to have this do is take our sorted length and simply divide it by 2. And then, of course, store that in our variable called mid. So now when we think about the median and how we calculate it could be different depending on if it's an odd number or if it's an even number. If you have an even number of values, then you take the middle point of that and then go up one or down one and down one, and then find the average of those two, and that's the median. If it's odd, however, then the median is just that middle number. So we need to check if that array length, that data length, is even or odd. And how we can do that is by what's called a modulo operator, which is a percent sign. And we can take that length and find the remainder of the division of 2. And if it is 0, that would mean it's even. If it's 1, it means it's odd. So how that would look, let's create another comment here so you can see what this piece does. Length is even or odd. So what we need to check is if the sorted length, finding the remainder after dividing it by 2, is equal to 0, which means there's no decimal place after that. It's an even number, it's flat. And if it does equal 0, then we want to return the average of those two middle numbers. So if even, there we go, we want to return this sorted. So since it's even, we're going to need to grab that midpoint, which is going to be the decimal, right? Which is going to have that decimal value. It's going to be in between those two numbers or whatever. So you need to go down one and then that middle and then find the average of those two numbers. So first we need to grab those, and that is going to be the mid minus 1, that number lower, and then plus sorted mid, and then we need to divide that by 2. And then that will give us that one. So now if it's odd, since there's only 2, we'll just say else. If it's odd here, if odd, then we simply just need to return that middle number. Return, and it's going to be sorted at that mid number. Okay, good. So that should take care of that. So now let's test this. Let's save this first. And then let's create a test function. And we'll call this median test. And the first thing we'll do is let's create a constant. We'll call this numbers. Now let's give it an array of numbers. Let's say 3, 9, 1, 4, and 7. Now what we're going to need to do is send that over to our calculate median, and we'll store that in a variable so we can log it out. Const, we'll just call this test number, and this test number is going to be equal to the calculate median, and what we're going to pass to that as an array is our numbers variable. And then let's log this out, and then let's see what we get. So let's save it, and then we'll run this median test. And it should give us the median. Now remember, this median, this has 5 elements in it. So it's going to simply be whatever this is. So 1, 3. So this is actually going to be sorted to be 1, 3, 4, 7, 9. So it should simply be 4.0. So let's run this and see what we get. There we go. That's the median. So now say we wanted to give this a different number, and let's say we'll do 10. So now it's even. It needs to find the middle point, and that middle point is going to be 1, 3, 4, 7, 9, 10. So it needs to find that middle point, which is right here. And what we're going to need it to do is 4 plus 7 is 11. And then we need to divide that by 2. And that should give us our median. So now let's run it. See what it gives us. Should be 5.5. Yep. There it is, 5.5. So now let's actually give it 100 and see what it does. 5.5. And we can change this to like 27, and it's still finding those medians. Okay, good. So awesome. So now we have a helper function that is going to do our median calculation for us. And we'll change that back. There we go. So now what we need to do is find the quartiles of this. So I'm not going to go through, because that would take pretty much an episode itself, trying to explain the mathematical formula or how you manually find the percentiles. If you would like me to put one of those together, I'll be more than happy to. But for now, it's just under the assumption that you know how to do that. And we're just going to write the code for it. So let's create another helper function. We can get rid of this test. We'll save it. And we'll call this helper function calculate percentile. There we go. Now this percentile is going to need 2 arguments. One, it's going to need an array of data, and then it's going to need to know what percentile it is that you're attempting to find. Now, ideally, we don't want to pass just one percentile to here. We want to pass, an array of percentiles. So let's just call the array, let's just call it data, and then we'll call the percentile array, let's just call it percentile. That'll work. So the first thing that we're going to need to do when we find our percentile is sort the data. Now, we know how to sort the data. Sort the data is going to be that. So let's create another variable, and this time let's just call it sorted data. And that sorted data is going to be this, so we can just grab this and put it down here. Very useful code snippet. Okay, so now we have that. Now we're going to need to find that midpoint, and that midpoint is this. So we can simply just, well, we don't really need to do that. We do need to find the data length, though. We don't need the midpoint. The data length, let's just call that n, because mathematically the number of elements that you have or the number of items that you have is just simply represented by n. So we'll just call it n. And that n is going to be equal to the sorted data dot length. Yeah, we really don't need the mid. We just need to find the percentile lower and upper values. Okay, so now we have that. So let's now calculate the index for the given percentile. So whatever that percentile is coming over, we need to give it an index, so to speak. So we need to take that percentile, whether it's 10 or whatever, divide that by 100, and then multiply that by n minus 1. So I'll create a comment here, and we'll just say calculate the index for the given percentile. And how we're going to do that, we'll create a constant. We'll store it in a constant. We'll just call that index for now. And that index is going to be equal to the percentile, whatever is coming to it. And we need to divide that by 100. And then we need to take that and multiply it by our length minus 1. N minus 1. Okay, there we go. And if you look up the calculation for this, the actual formula, this is going to start making more sense if you have no idea what I'm doing here. You'll say, oh, okay, so that's where he's getting the n, that's where he's getting the minus 1 and all that. And then what we're going to need to do is take that index and find the lower and the upper index, and we can do that with math floor and math ceiling. So math floor finds the bottom, math ceiling finds the top, essentially. So let's do that. We'll say this is going to return or store the variable, better yet, the value of the exact index point. So let's create a constant and call it lower index. And that lower index is going to be equal to math dot floor. And that math dot floor is going to be of the index. And then we need to do the same exact thing to the upper, and we'll call that upper index. And this is going to be math dot, not floor, ceiling of that index. Okay, so that should be good. So now what we need to do is, if that number is an integer, we want to return that exact value. So let's check to make sure that it is an integer. First, say lower index. If lower index equals upper index, then we want to return our sorted data. So this kind of should be true here. If we want to return the sorted data at this lower index. Yeah, the lower index. Okay, and then we should get out of that if statement. So now here we're out of this if statement, and we're back up here to our function, or we're back up here to our function, excuse me. Now what we want to do is return that actual percentile amount. So we need to essentially return that lower value and the upper value, or we want to find that lower value, upper value, and then we want to return those two values. So this is going to look like this. Return the two, we'll just say two nearest values, and we'll create a constant and call this lower value. And this is going to be equal to, the lower value is going to be equal to the sorted data at the lower index. And then we need one for the upper value. And that is going to be equal to the sorted data at the upper index. Exactly. And then what we're going to want to return is the actual formula for the percentile, now that we have all the data figured out that we need. So it's going to be the lower value plus our index here, plus the index minus the lower index and then we're going to need to multiply this by our upper upper index, no, our upper value minus lower value. And then that should give us our percentiles. So let's create ourselves a test function for this. And we'll call this test function, let's just call it %test. Let's give it some numbers. We'll call this numbers. And we'll say this is going to be equal to 3. Now let's give it some more. Let's say 12, 15, 14, 10, 18, 28, 17, 19, 13, and 16. Now these would be salaries, obviously. But for our test, we'll do this. And then let's give it some percentiles. And our percentiles are going to be 10, 25, 75, and 90. So now what we need to do is log this out. And I'm going to use a literal here. I'm going to run a for each for each one of, I'm going to run a for each for each one of these percentiles here and then have it populate. So how I'm going to do that, because it'll be easier to show it, I'm going to do a for each on our percentiles. And we will say, we're not using a row, we're using a percentile, so we'll just say P. And what we're going to do is for every one of these, this 10, 25, 75, and 90, we want to pass it up to this. So let's create ourselves a logger log. And then let's do the literal here, excuse me. And what we can say is the $ curly bracket P. So that's whatever that percentile is, the 10th percentile, is, oops, there we go. And this is going to be this calculate percentile. And we need to pass, the data through it. Nope, not the data. We need to pass the numbers through it. And that P, whatever P that is. Okay, so let's make sure that we are going to close out things here. Close that out, close that out. Okay, good. So let's save this and then run this function perk test here. And then we should have the percentiles of this array of numbers at the 10, 25, 75, and 90. And there we go. So obviously the median is going to be right here somewhere, 15 something, maybe 1550, somewhere around there. So now we have the 10th percentile, 25th, 75th, and 90. So now how we're going to be able to integrate this into our dashboard here is, instead of hard coding our numbers, we can simply store the returned value of salaries, that returned array, and then pass it up there to it, and then pass 10, 25, 75, 90, and then populate those fields with whatever that's returned. And then we can just add that to the end of our calculation pieces right here and have it do just that. Instead of calculating the average, we'll just calculate calculate our median and calculate our percentiles, and then pass either the salaries and whatnot through it. So good. We have 2 working helper functions to find that. In the next video, we'll start doing something with those. We hope that this has been informative. If it has and you like what we're doing, please hit that subscribe button. And until next time, please take care.